this is Eric Andelin with SimActive, and we're just on hold. We're going to wait a few more minutes for a couple other folks to get online. I can see people starting to show up. In just a minute, we'll start the presentation. All right, one more minute. Okay, we'll let the others catch up, or they can watch the recorded version later on. Again, my name's Eric Andelin. I'm with SimActive. I am a senior workflow specialist. And on the line with me here, I also have guest speaker Brian Leiser, principal and LiDAR and 3D mapping expert over at Redefined Horizons. Brian, say hi.
Hi, Eric. Thank you very much. Brian Leiser. Yeah, I'm one of the owners and principals here at Redefined Horizons here in Northern California.
Great. So we'll go ahead and get this going. I know we have an hour. We'll try to keep it to that. But here are a couple things that you'll learn. We'll talk about mission planning, specifically to the Skydio. We'll talk about data acquisition and post-processing, performing the AT, generating deliverables, DSMs, DTMs, and orthomosaics, and then how we assess final project accuracy. But let's start with a little bit of information about Redefined Horizons. Brian, give us a little bit of background on yourself and the company. I know you and I have worked together in past lives at previous companies, but fill us in on Redefined Horizons.
Right. Thank you, Eric. Yeah, Redefined Horizons, we're a small, primarily land surveying and land development company here in Northern California. But we also provide geospatial services, primarily in the form of UAV deployed imagery and LiDAR. So I have about 14 years of experience myself, and I've done work anywhere from the private sector on up to state and federal agencies like the California Department of Water Resources, the FAA, and the Department of Defense.
Great. So I know that you, like you said, you've been working with drones quite a bit. You have more than just the Skydio system, but fill me in on how you guys got hooked up with Skydio and what you think the benefits of are that system. Obviously, it is certainly a modeling tool. It's great for that, and it was designed for that with its sense and avoid technology. But we see a lot of people start to look at it and say, "Hey, I don't want it to sit here when I'm not modeling something. I'd like to use it for other applications." And I know you guys are starting to use it for mapping. So let us know a little bit about your relationship with Skydio.
Right, and you really hit the nail on the head, Eric. We are Skydio enterprise customers. And primarily, the system was designed as an asset and structural inspection platform, right? So for very close-in inspection, the world-class AI and obstacle avoidance is really what makes it the best tool for that purpose. Combined with the software, in particular Skydio's 3D scan. But honestly, being a small company, we do need to use our assets as judiciously as possible, right? So we want to be able to deploy them in a multi-role kind of a capacity, and so Skydio actually comes in handy for mapping small land development projects, for doing orthophotography and creating DEMs.
Good. That kind of takes us into the next part of this, and we've got a demo project. We've got a project that you've done. Actually, it's not a demo project; it's a real project where you've done some work, small land development, and we'll get that loaded up here in a second. But I know one of the challenges with Skydio, and I have conversations with them, as well, is that originally there was no tool built within Skydio to set up a 2D mapping project. What was there before, again, was draw a 3D box around a structure, and then Skydio knows to go in that box and stay in that box and capture information of everything in there. But now when we start talking about nadir flight, where we're trying to map, property, I know people have done it manually. I know there's a couple third-party tools that people have been working with, but I also hear that Skydio has got something built internally now that allows you to do this. Do you have any experience with these?
Absolutely, and we've been testing that, Eric. So you're right about previous releases of their enterprise apps did not have a very robust methodology for doing that kind of asset capture, for doing those types of nadir captures. Mm-hmm. With their latest release, they have fixed that. They call it 2D GPS scan, and it works very much like any other traditional flight planning and mission control software that have been out for quite a while, right? And so it works very well. It does all the things you would expect it to do, and it's great for us. It's allowed us to actually do away with previous flight and mission control software we had been using for this. And this brings everything in-house as far as into the Skydio ecosystem, and we really appreciate that they did that.
Very cool. So now we're getting missions planned within Skydio. The imagery is automatically geotagged. It's in the EXIF information. So we're really to the point now where we can start doing some mapping. So I've got a couple slides here, and I've got some example data. So let me pop into the next slide here and just again talk a little bit about what we're doing with these data sets in SimActive. So what our workflow typically is we import the imagery, we do type point extraction. If there are GCPs, we can measure the GCPs and the checkpoints. From there, we would do a bundle adjustment. After that, depending on what the deliverable is, what the desired product is, we can produce digital surface models, digital terrain models. We can modify those. So we've got some editing tools, DEM editing. From there, then you would do your orthorectification and generate your mosaics. And then again, if there's editing that needs to be done in the mosaics, you can do that as well. So what I'm going to do right now is I'm going to pop over to the actual project. So bear with me. I'm an old man, so Windows can freak me out sometimes. But let me get Correlator3D open, and you can see we've captured some of this data. So we'll get back into that here in a second. Okay, so when we open Correlator3D, obviously you have network license options and local license options. We've got a local license here, and we'll get this to open up. So here's Correlator3D. This is our user interface. It's asking me to do an update. I'll let that slide for right now. So across the top, going left to right, are all of the steps that can be performed within Correlator3D. We also have a directory tree for all of the products that you're creating within Correlator3D. Over here, this is a new button. This is our distributed processing button. You wouldn't really be using it on Skydio projects because they're going to be small, but if you're doing large format processing or medium format, or say BVLOS drone stuff where you're capturing 10,000 images, you might want to do some distributed processing. But right here, if we want to create a new project, we just select that. We're working with UAVs with Skydio, so we've got this. It's only got one camera, so we leave everything alone there. And we can now go ahead and add the images. So we can add images individually, or we can add the entire folder. So what I'm going to do is add the entire folder. And I'll get to the project. So we actually have a lot of images in this project, probably more than we needed. So I actually created a folder and I just took half the images. So we'll use half those images, and I can explain more of that here a little bit later on. But it's loaded the imagery. We have the lat long and the altitude. It was collected in meters, so we leave that alone. Then we're going to go to the coordinate system that we want the data set to end up in. So this is California State Plane Zone 3, right? 2227, there we go.
That is correct.
Yeah. And you could, if you wanted to, is in common systems, if you went up here and you just wanted to rattle through it and go state plane, you know, all that, you could do the same thing and get to the same result. It's just, if you know the EPSG code, go for it and push it through faster. Now, you know, truth be told, I'm going to let you know that I have a data set that's processed, and we're going to start with a data set that's not. Once we get so far into this process, for example, when it comes time to measure the GCPs, nobody wants to sit around and watch us measure 20, 30 GCPs. So we'll do one, and then we'll go to the process data set. But once we have this, you can see that now we have assigned where the projection is going to be. We select next, and you can see we've got a couple options here. It's going to pull in all the information on the camera that it knows. And honestly, that update that we saw earlier was probably an update that included the pixel size for this camera. I just happen to know it's 1.55. So we'll go ahead and set that. We could also import a calibration or a camera EO file if we had one or needed one. But this should be updated so that will come in automatically as well. Then we create a project folder. So we'll go ahead and find a project folder, and we'll just call it, create a new folder. Call it that. Now this is where Correlator3D is going to put all of the project information. So we'll select that. If we had an existing surface model, we could add that. If we had a GCP file, which we do, we could add that as well, but I'm a graphical person. I would like to see that when I load it, so I'm going to wait a little bit. And then also reference orthos, we can add those as well. So I'm going to click Finish here. So here are all of our images, and they're nicely displayed over a satellite image of the same area, so that you can tell that you're in the right location. Right, Brian? We're in the right location?
Looks great to me, Eric.
Okay, perfect. Great. So we'll go ahead and let that go. The first thing you're going to do across the directory tree here is, well, let me back up. Let me talk about this one. We do have a black box option. If, for example, you were just going out and flying this and you wanted a quick mosaic, you could go in here. Correlator3D is a script-based tool, so which means you could run this command line and never look at the user interface if you didn't want to. However, in that, we've created a handful of generic scripts. And in those generic scripts, you can see all the steps in the process going top to bottom. And as we pick from one to another, true ortho or fast ortho, you'll see that these settings change a little bit. So what happens when you're done is it's creating a script and then it's running that script. Works great if you don't have control and you just want something quick. Or if you have PPK and you just want something quick. So we'll let that go for now, but I just wanted you to see that that's there. I don't know, Brian, have you worked with that at all?
I have not used the scripting function yet, Eric. That's something I really would like to do a deep dive into, especially on larger data sets.
Yeah, the command line tool is really awesome because if all the projects are the same, you can kind of just put them together and daisy chain them and then just let them run at night, and it does really well. But I'll also show you, because I'm a photogrammetrist and I love this stuff, I'll show you how to do these steps manually, which is typically what I would do. The first thing we will do is perform, get into the bundle adjustment portion of it. We do need to generate tie points so it gets a rough estimate of where it's going. So we'll go ahead and let it run this tie point estimate process. It's going to take a few minutes, but we're live, so we're not going to jump out of this. But Brian, this project, can you give me a little bit of information about what this project's about?
Yeah, so this was a typical land development project, Eric, and it's small enough to where Skydio was perfect. And honestly, we could have deployed, a much larger, more obtrusive rig in order to collect the data.
Sure.
But one of the benefits really that most people may not think about with Skydio is that it's very small, difficult to detect, and it just doesn't get in people's faces. So being good neighbors as we are, we take a small system out there, doesn't have a large footprint, it doesn't attract a lot of attention, and we don't bug people with a larger, more noisy, obtrusive system. So it's really one of the benefits that we didn't intend that from the start, but it really is there. It does exist.
Yeah, having worked with different types of drones, I know in a previous company I worked with, they had one of the Harris drones, which was gas powered, and it sounded like a leaf blower, even from 400 feet. So the stealthiness of the Skydio and drones that are much smaller, there are benefits to that for sure.
Yes, and that's important. I mean, we want to be good stewards of our industry, right?
Yes.
And we are professionals at this, but there's some folks out there who are not, and we want to make sure that we aren't lumped together with those folks. So it's really important to us that we kind of exercise that good neighbor policy.
Yeah, absolutely. While we're looking at this, is waiting for it to finish here, I'll point out a few things. Once we went into the AT module, you can see over here on the right side of the screen, top to bottom, are the steps within that module or options that you have. And the first one is flight line editing. So, for example, if you had overlapping photos where you didn't need them, you could go in and eliminate those. And by eliminate, I mean take them out of the equation for the processing. It's not actually getting rid of the photos. And you can also, for example, if you have flight lines that are disconnected, you can tie them together and things like that. Right below that, we have GCP, so importing a GCP file. And we'll go ahead and do that since it's one part of the project here. We've got ground control here that Brian provided, and we'll go ahead and set that up. So it's importing a text file. You give it a name, you give it its position, and we should be able to import those. And they're here. You can see them. They're hidden right now, but they're little blue triangles. I'll show you that in a second. But what happened was it just did a quick initial adjustment to get the images kind of in the right place to relationship to each other. So this is not the bundle adjustment, it's just a tie point collection. But you can see the disks are color coded based on approximate error. So these have a little bit more than 1.5 pixels right now, and we'll resolve that fairly quickly. We also have the ability to change what we're looking at here. So if I changed it just to the kappa, it would show us the direction of photography, the direction of the camera in the flight line and so forth. And if we really want to see the control points, the GCPs, we can turn off some of these features so that we can see the GCPs lying down in here. So there are options to look at this stuff. So the next step we want to do, and I'll go ahead and put this back, is we want to measure those GCPs. So once we loaded them, they end up right here. So we have GCPs, and again, for the sake of time, we'll breeze through this, but I'll show you. And you've seen this before. I could go ahead and say, yes, do a tighter bundle adjustment so that GCPs come in better. But for this example, we don't necessarily need to do that. So it's going to, I accidentally did tell it to do that, so let me pass on that. Yes, I'll cancel that. And we'll get here. It's going through that. So we go through a handful of iterations when we're doing the bundle adjustments. And like I said, it's going to bring up the where it thinks the control points are in relation to the photos that cover those areas. So we're close, and that's fine. We'll go ahead and measure this 1 point, and you've seen this before in other software. It's very similar. As you put two together, it's going to start aligning the others as best it can. When you run a bundle adjustment, it'll bring them in even tighter. So we're going to do that here in a bit. But I'll go ahead and accept. I'll go run through these. Bear with me. Brian, I like your GCPs. Your target layouts are good.
Yeah, and we have a custom design template. I'd love to say it involved a lot of artistry, but really it was primarily focused on practicality.
Well, you know, the funny thing is people don't think about just something simple as numbering. You know, I can see we've got 301 numbered on there, so I know is somebody coming into this blind, I know where it's at, and I know I'm collecting the right one. So that's helpful, especially if they're close to each other. So let me get through these.
And that's really a time saver, Eric, in the office, because the person doing the processing may not necessarily be the person that was in the field collecting the data.
Yeah.
And so it's really an initial QA step.
It absolutely is. And, you know, the reality is like you said, you've got surveyors out in the field collecting this information. They may not be the ones processing it. And I can't tell you how many times we've had to have discussions with the surveyors. Okay, which target was this? You know, so it's very helpful. So what we would do is we would go through and we would measure all of the GCPs. And I can show you this as well. We do have checkpoints in this project, so we'll go ahead and add those too. Now they could all be combined in one file, but you know, Brian was nice enough to give us separate files, which is great. So we do have checkpoints, and all I'm going to do is go right here and call them checkpoints. So what we're going to do in the software is going to measure those points, but it's going to withhold them from the AT solution, from the bundle adjustment, so that we get a valid measure or a valid measurement on those points. Let's see, so we've got those added. Go ahead and assign them just like we normally would. I got YX, my mistake. YXZ, and Brian's given us some information on those points, so we've got that as well. But we'll go ahead and we'll bring those in. Now we have a checkpoint file. The one thing I would say as we move through this, and let me get to my PowerPoint here. When we go through here, again, here's just a PowerPoint slide of the same thing, project. And we can see all the control points. The checkpoints are listed. They look like hourglasses. One thing you'll notice is the checkpoints in this case are very close to each other. In fact, they could be two different sides of an ADA ramp. So my comment to that, and the reason I bring it up is when you go into Correlator3D, it's best to run a bundle adjustment on the GCPs so that when you go to measure the checkpoints, it'll show up right exactly where they are. And let's flip over to one that's already been processed so we can show you that without me having to measure all of these GCPs. So I'll get out of that. And we'll let it go. Right back in. Correlator3D. Went too fast. I went in a hurry. Second here. There we go. So I'll select my license and it'll go ahead and open it. And here we'll open one that we've already processed. So we'll open here. Let's browse and find it. Here. We'll call it demo. We'll open the demo. Here we go. Here's the project. Now, I could have done that, I apologize, I could have done that just by opening project and selecting it here, but I happen to know where it's at. So this one's been processed through, but let me turn off the features and we'll talk about what we actually did here. So let's go ahead and turn off the mosaic, and we'll turn off the DSM and the DTM. But we'll look at the GCPs, because this is where we were. And we'll pop back into AT. So when we originally did the adjustments, we processed just for the GCPs, and I think that's right here. Let me double check. We got a quality report, and it's okay. So I did, in this case, I did one ground control point to tighten things up. Once I did that, I did another adjustment having measured all of them. So we've got all of the ground control points. And one thing you're going to notice here, and Brian, you'll recognize this as well, the results are pretty darn good. Looking at the measurement to the ground control points, things look really well. The image tie point, anytime you see excellent here and you see nothing but green points here, that means your error is less than right around half a pixel. So 109 tie points for all of these images on average. They came out really, really nice. We did full AT unconstrained, and I'll show you that, which just means we don't have PPK. Skydio doesn't have PPK. We're letting the software do the adjustments. And then a little bit about the camera itself, how it adjusted the focal length, things like that, and then the error. I also processed it through with the check shots. So here we can see again, our error is very, very tight here, and everything looks good. Even the check shots look pretty good. They're under 0.2, which is nice. But I'll show you how we did that. So if we go into the GCPs and, for example, we want to measure a checkpoint. So in this case, and Brian, give me a little bit of background on why you did this. It's probably project specific, but you, for example, on this one, you have a checkpoint on this corner and you have a checkpoint on the other corner.
Right, and that's really purposeful, Eric. And the reason why, number one, of course, as you know, you want something that's easily identifiable in the images. First of all, if it's not going to be an actual target, and sometimes we'll do that too. We'll install additional targetry. But in a case like this, the subject matter here, it had a lot of stuff that we could easily get to: corners of ramps, corners of vaults, and striping, and in some cases. And sometimes when you're shooting stuff like this, it can be difficult to know for the person processing, all right, what corner of a stripe did you shoot?
Exactly.
And so if you capture multiple corners of a stripe, it becomes very obvious to the office processor what the field surveyor was trying to accomplish.
Yeah, and that was kind of the point I was getting at on when you're measuring these. When you do the GCPs, go ahead and run the whole bundle adjustment. That way, when you open up and you go to measure the checkpoints, it'll be right where it should be, so you don't have to guess, for example, on this paint stripe, whether it's the top or bottom. So that, helpful little tip there. But the actual bundle adjustment process is after you measure your checkpoints or your GCPs. Then you go into the bundle adjustment. You do, in this case, full AT unconstrained, which means the software is going to do the work, making the corrections. It's going to adjust the XYZ values, the omega kappa phi, and create the best solution. We do unconstrained calibration on the sensor because in all reality, drones don't really have calibrated metric cameras in them. Even those that say they do really don't necessarily have that. That's more of a large format, large aircraft kind of thing. So we leave that alone. Back to the EO adjustment. You do have the ability to select other options. For example, if you did have a RTK or PPK assisted system, you could do that. In that case, it would hold the XYZ value of the image as it was captured, but it would still allow the omega kappa phi to be adjusted because, again, IMUs and drones aren't real IMUs. They're just close. So we still want to be able to adjust that. But here, full AT unconstrained is what we would have done. And then we also have an image filtering tool. So for example, before these were processed, there may have been images that were out, again, more than 1.5, more than 0.75. Here we could just go in and say, I want you to exclude all those or automatically exclude the bad images. But we've done that. We've processed it, again, for the sake of time, which is about, in this case, I think it was 7 minutes to process out the AT. We'll move on past that point. In general, Brian, any comments on the AT and the processing side of things?
No, you've covered it very well, Eric. Although I will interject if you'll allow me. It's another feature that works really great is the ability within Correlator3D to register to the intensity map for
Yes.
LiDAR point clouds. It's something I've done a lot, and it works absolutely fantastic.
All right, I'm going to get you in on that webinar too, because that's my baby right there. So we'll talk about that one in a bit. I love it, especially when you got mobile LiDAR or low altitude drone LiDAR. It's outstanding. So once we're done with this, once the AT is done, it creates that report. So we've seen the report. It also, you have the option here to create a course elevation model. Typically, we don't do that. It's not necessarily needed. If you're, over areas where there's water, you might find that valuable to start you off. But we'll go ahead and let that go. We'll get out of the AT module, and now we'll start looking at producing the other deliverables. So if we look here, we've got a DSM and a DTM, and both were produced up here. So once you're done with AT, you just select DSM. It's going to estimate the resolution, and typically I think it's maximal is a 1-to-1 pixel comparison, and optimal is a 3-to-1. 3-to-1 is perfectly fine. You'll find you get a good data set out of there, and optimal means it's going to process in the optimal way. If you go the direction of maximal, just consider that you're changing your processing time by 3 or 4x. So be aware that you probably don't need it. And then you have some adjustment on your vertical accuracy of the output DSM. One thing that makes us different is although we ingest point clouds and we can create point clouds, we are elevation model based, so we produce DSMs and DTMs. Outputs from that can be something else, but we work with those primarily. So were we to process this, it would run through and it would generate the DSM. When it's finished, the next step would be, obviously, if you're working with land development, what you want is the ground. So the next step would be to go here and extract a DTM. And you can do a couple things here. If you had some constraint information, you could include that. If you wanted to output the difference, in other words, what it strips out of the bare earth or what it strips out of the DSM, you can put that in a separate file and have it. And that may be useful for editing functions when, for example, you want to keep certain buildings. Maybe you want to keep the buildings and get rid of the cars, things like that. So you have options there. And your DTM will look like this when it's complete. Oops, sorry. I bounced between the two. So your DTM is going to look like this. It's cleaned out almost everything that it can. Similar algorithms to what they're using in LiDAR to do the same thing. Obviously, the difference is that a DSM is a point representation of the first thing it sees. So we don't have multiple returns like we would with LiDAR. We've got a couple other things we can do here. You'll notice that down in the bottom we have a 3D view of everything we've got captured here. We have the ability to turn the images on and off, so now we can see the footprints. We've got tools like that. If I don't want to see them in here, I can turn them off. The control is still there. I can turn off the control points. You can see those go on and off. But you've got some tools there as well. When we finish that portion, we could go into DEM editing. So, if I wanted to go in here and edit an area in this DEM, for example, I'll just say, okay, I highly doubt that this area is a dip in the grass. It's probably, something else, and I want to flatten it out. I've got options here. I can set the elevation. I can go ahead and just delete and fill. I can delete and fill, preserving the topology in the area. So you've got a couple options there. If I wanted to extract that piece to something else, I could. But let's just say we wanted to fill it in. So now we've filled it in, we could save it, and we could move on. So that's just a quick touch at the DEM editing. You could certainly do a lot more. If I wanted to go in here and I said, well, this area is probably a little bit flatter. I can go ahead and do that. Same thing. So we have that ability. Once we're done, we'll save it and we'll move on. So I'll go ahead and jump out of here. And our DEM remains in that. Do you do a lot of DEM editing, or you find it pretty close, Brian, when you work with this?
You know what, Eric? It's actually a critical feature of the software, and really depends, of course, upon the subject matter and the intent for the data set.
Yep.
But they're very powerful tools. I use the filtering tools a lot, especially if you need to orthorectify buildings and things of that nature.
Yep, yep. So, you know, obviously you can get much deeper into it, and if you start to want to do some heavy lifting in the editing, you know, maybe outside of Correlator3D, you might have other options you can do. You can always take this, either one of these surfaces, into other software and do your work there as well. So, but we just wanted you to be aware that we have those tools. Once we're done with that, I'll go ahead and turn it back on. Once we're done with that, we go into the ortho rectification side of things. So it's going to tell me that I must save the DEM. That's fine. I'll save it. But here, now we've got some options here. And one of them I wanted to show you. Remember, I said that I went with half the images. One of the reasons I know I could do that is I see the overlap right now is it's 68% still, which means that Brian collected at what, 80% overlap to start?
Yeah, I sure did, Eric.
Yeah, okay. So that's obviously the beauty of drones and the beauty of digital imagery is that you can capture as much as you want. It doesn't cost you any more, which is always a good thing. Always over capture beyond your boundaries and so forth. But when it comes to processing, you may want to reduce the number of images because obviously it has to do with processing speed and file size and those kind of things. As a photogrammetrist, I've gotten to the point where I can look at those original images and say we've got enough overlap. We could probably cut it down. Also, based on what our goal here is with the deliverable, we can cut it down a little bit. So here it's showing us that the maximal overlap is what it's using is 68%. So that's saying on average we have 68% overlap. So we can go with that. We could tighten it up and we'd say optimal and it would only use 30%, but you know, for color balancing purposes, we'll use all of it. You could also, if you wanted to crop specifically based on, you know, top, bottom, right, and left, you could do that. That used to be done a lot when vignetting of the images were an issue and so forth. Now, not so much. We don't need to bother with that. Another feature up here is true orthos. If you're working in an urban environment and you're trying to keep the shape of the buildings, then you're going to want to select this as a true ortho. It's also going to pull the surface from the DSM and not the DTM. In this case, it's land development. We're talking about ground, so the DTM is where we really want to be. Also, you'll notice down here it's giving us a resolution. So the optimal resolution right now is 0.06%. So we're going to work with that. Actually, I'll probably back it off a bit because what is 0.06 feet? I don't even know what that is. So I know 0.8 is around what, an inch? So we can work with that. Brian, is my math wrong there? But I think 0.08 is around an inch.
Yeah, you're doing pretty good there, Eric. Yeah, there's no reason for that type of resolution for this particular project.
Exactly. So, you know, for the sake of argument here to run it fast, we'll just say 0.125. We'll process it. In this we can watch in real time because actually the ortho process is fairly quick. So we'll let it go. And you can see it's actually populating those images as we produce them. I should get back to my PowerPoint slide, but I actually like looking at the real processing more than the PowerPoint, so we'll continue on this way.
It's a little bit of the payoff for all your hard processing work, isn't it, Eric?
That's right. That's right. So these are going through, and you can see we now have ortho-rectified images coming up. They're not color balanced. You'll notice that, and we're not in that part of the process yet. But it'll be done just here in a second. Okay, so we've got everything covering the entire project, and you can see that it's loaded them up here. I'll go ahead and minimize that. I can also turn off the reference, let's see, the online data, so you can kind of see this is the area that the ortho rectification was done of. The next step is creating the mosaics. So here we've got options as well when we create the mosaics. Obviously, typically you're not going to give your customer this image here. You're going to want to put your boundary on it, so forth. So you probably want to clip it to the boundary or just beyond the boundary. So if you have a shapefile, you can do that. Just import the shapefile. If you have exclusion zones where you want the color balancing to, where you don't want it color balancing, you can load those. And again, for nadir optimization, what it's doing is it's again, because we do a little bit of modeling as well. You want nadir optimization. We're not doing modeling in this case. We're looking straight down. You also have the ability to use the loaded DEM for seam line obstacle avoidance, and what that means is if the DEM has structures in it, buildings in it, when it goes to draw the seam lines for the mosaic, it's going to do everything it can to avoid running through that structure, so that we keep the surface and the view of that structure complete. In this case, again, we're worried about ground, so let's move on with ground. So we process this. It's going to tell me it's not empty. We can go ahead and do that. The mosaic process goes by pretty fast as well, especially with a number of images here. I think we're around 350 images right now, so it's still quite a few. Again, Brian, you can talk to this. The limitations of the Skydio, obviously 12 megapixel camera.
Yeah, and it's important, right? And so it does limit us a little bit, at least to what we think our maximum flight height should be. We don't fly at 122 meters, but for most cases we can fly between, say, 150 to 200 feet, something like that. And that 12 megapixel works just fine for that. And honestly, the Skydio has tuned their camera system to give you better results than what you would expect from a 12 megapixel camera. And just like you explained earlier, Eric, we're there. Anything worth collecting is worth collecting a whole bunch of, right? As surveyors, that's how we look. We want to over acquire our data. So I believe we had around 800 images for this particular project. That's a lot of images, but as you said, it doesn't cost anymore. I'd rather use another battery and spend another 15 minutes in the field than have to redeploy to the site.
Yeah, and that goes back a little bit to what we were just talking about in the beginning with Skydio's new ability to create mission plans internally. It's not such a hassle to go out there and fly, say, 3 missions of this area.
Yeah, and it works really great, even with multi-battery missions. The thing comes home, it lands, you put another battery in there, and off it goes, and it goes to the point where it left off, and it makes things really easy for the field crew.
Right. So, and I mean, the fact that you're using a 12 megapixel camera means you're probably flying closer to 200 feet and not 400 feet, which, from your own safety perspective, you're kind of happy that it's not all the way up there at altitude, especially if you're in an area where there might be aircraft around. It's nice to be at the 200-foot range. So,
absolutely, especially with a small drone system. Absolutely.
Yeah, I think that's a nice little benefit as well. So we just went through the mosaic process. It went by pretty fast with the images. You could see that the tone balance looks good. If we zoom in on features, again, we didn't create the tightest output here, just for sake of time. But everything looks pretty good. We can even see that our targets in our mosaics are matching our GCPs. So there's no rubber sheeting going on of the mosaic to the control points. I know that happens in other software. We don't do that in ours. So that's a nice little benefit. And you can see we also have, like I said, the 3D window. We can flip this back and forth. So if you want to see the 3D view versus the 2D view, you could do that. So we've got that, and you can see it is of pretty much bare earth. We've got the railroad tracks there. If, for example, I turned on the DSM, it'll go ahead and do that. Let's see, I'll flip them back and forth. Now you can see, you know, a little bit of the difference of what it would look like if the DSM was involved, because now you've got the trees and all those kind of things involved. So benefits to both for sure. That's why we like to create them both. I'll switch back, and here we go. We could change a little. We could stretch the display a little bit. We can adjust the brightness, things like that. Obviously, you could go to grayscale if you wanted to. You have all those options. We also do volumes. So I'm going to go ahead and I'll turn the orthos off. We'll go back to the DSM. Bear with me while it loads. Oh, turn my mosaic off. So if you had an area here where you wanted to do volumes, you could certainly do that. Maybe, I don't know, this is not the perfect example, but if you wanted to do a volume in this area, you go here to select and measure volumes. And you can just go ahead and select the area. I kind of cut that one off. There it is. Oh, that's the profile. I apologize. It's giving us the profile there. But you could do profile. So profile would be just this, straight across there, and it's showing you. And then as you move across that profile, you see on the screen, it's actually following that path as well. If we want to do a volume, we're on the volumes here. Yeah. Select measure volume. Hopefully I got it this time. Yep. Let's see. I can just select the measure volume button here, and it's going to give me a couple options based on how you want that volume to come out, and then you just process it, and it's going to tell you how much that volume is for that area. A nice thing is if you have a shape file with these, you could load it. So you could load that, you could save it so that you've got it in the future. So you've got a couple options there. I know I'm seeing questions come up on the side. Believe me, we'll get to them when we get a chance. If we don't get to them through the presentation, we'll go ahead and get to those afterwards. And then any additional information we have, we'll be happy to answer at that point as well. Let's see. So let's go back to the mosaic. And I'm going to pop back to the slide here just for a second, the PowerPoint, make sure that I did not miss anything for us. So we talked about, yep. So we talked about the AT and how to perform the AT. Again, I think the key points there are measure your ground control first, do a bundle adjustment of the ground control, then go back in and do your checkpoints. When interpreting your data quality, what you want to see is all green here. You also want to see this say excellent down in the quality report. Oh, excuse me. We can create the DSMs and the DTMs. The DTM is your bare earth. That's what you want when you're working with land development. Creating the mosaics and the orthos. So the first thing we're going to do is build the orthos, determine the overlap that we want those in, whether we want them to be true ortho, which then would take into effect buildings, and then disabling images, which ones you want in the process, things like that. You can turn them on and off. Creating your mosaic, and then assessing the accuracy. So as you saw, we've got control points in that overlaying mosaic. If we would process that out to its highest resolution, then you could be able to zoom right in and see that the checkpoints are sitting right where they are, not only vertically but horizontally. And one thing a little bit outside of what we're doing here, but what I wanted you to see is another way to check your accuracy. So let me pull up Excel here, and this is one that I use all the time. Brian, do you use this spreadsheet at all?
I've used it several times, Eric. It's a
Okay.
real time saver, and I like it a lot.
Yeah, the reality is I mean, we can create accuracy reports in SimActive. You can create them in whatever software you're working with. But when it comes down to it, when you turn that report into somebody with your final data, it needs to be something that means something, not just, hey, I've got a bunch of, colorized error-based images. So this one is actually the NSSDA accuracy assessment, which is basically the standard here in the US. It was developed in part by the ASPRS. And what's nice about it is you can determine what your acceptance criteria is, or what the acceptance criteria is for your product. So for example, if we take all of the checkpoints, we've got their actual values, so what Brian measured him or his team measured out in the field. Also, the value that we pulled from the SimActive reports. We can load them in here. It's going to give us a difference. It's going to give an RMSEZ and a vertical accuracy. So based on that, we know that for 1 foot contours, the vertical accuracy has to be equal to 0.3 feet or less, which we are. We're at 0.18. And to meet NSSDA accuracy, we need to be 0.06 feet or less at the 95% confidence interval. And we are. We're at 0.35. If you scroll down here in this little spreadsheet, you've actually got a couple other footers that you could add to it. So if you look at the 1 foot, I'm sorry, this would be half foot contour. I don't know if this is one. Yep, right here, half foot. We almost meet the criteria for half foot. So if you want to be that picky, you could probably remeasure it. You could probably get it down to that level. I'm an old school photogrammetrist, and working with engineers, do they really want more than half foot? Not often. But you do have that. Brian, any comments there?
Yeah, and a report like that, honestly, it can be very important for some clients, particularly if they're sophisticated when it comes to surveying or photogrammetry. They want to see those hard numbers, and you need to be prepared to provide those to them.
Yeah, absolutely. And I'll make that report available in the chat log, or make it available if people want it. It's a fantastic tool. The last thing I'd like to bring up, and we won't go into detail into it. You might want to look it up on our website, but we do have point cloud capability. So if you want to import a point cloud, not that I have one of this area, Brian did not share that one with me, but you could actually import a point cloud. So to do that, first we have to get out of the volume measurement tool. Then we go over here to import LiDAR LAS file, select that. Point it to the directory that the LAS file is in. You're going to want to extract a DEM as well, because Correlator3D is DEM based. Also extract the intensity image. So it'll create a reference ortho of the intensity image. You're going to give it an output folder and a name. But you can then use that intensity image, say the paint stripes or things like that, for additional control. So that's a nice little feature. We also do have a log file that keeps track of all the information for the project. As you scroll through down here, you can see all that information. But really, that's pretty much it in a nutshell. Brian, did you have any comments?
Yeah, I have used, like I said, you've already described the possibility to do LiDAR registration using an intensity map. Also, using reference ortho. So if you are surveying a site that you're going to do over and over, say, just as an example, you can use those reference orthos to detect changes on site.
Yeah. If you're working quarry sites, anything like that, where there's consistent change going on, you can always reload the previous reference ortho. We have change detection capability, so if you've got two elevation models that you want to do a comparison on, you can bring those in and do change detection. So there's quite a few options there. I know I've covered a lot here, and I've used my hour. With that, I'd like to thank Brian for helping us out. And Brian, any comments, final comments?
Thanks a lot for the time, and it was a real pleasure, Eric. Thank you very much.
So again, myself, Eric Andelin, and my guest, Brian Leiser. Happy to have been able to put this on for you. And again, if you have any other questions, leave it in the chat box. We'll make sure we get to it. You can also reach myself or us through sales@simactive.com. And again, thank you for your time.